I want you to take you through a question in microprocessors. There was a question, an assembly question, which was saying that you write an assembly language program that is going to add the sum of odd numbers from 0 to 10 and also do the count the numbers, the number of odd numbers. So I've tried to write the code here. So in the first instruction here, the first two instructions, that is move AX 01, move PX 01, just initializes the registers AX and PX with 0. Then move CX, you know CX is a counter register. This is where we are going to store the number of counts. You see we need 10 counts from 0 to 10. So we are storing the maximum value 10. And you know 10 in hexadecimal is there. The next value is that we are storing that value 10 into DX register. And the next instruction there is the test instruction. I know you know test instruction perform ANDing of the source and destination operands, but just affects the flags. So the concept we are using here to identify odd numbers and even numbers is that when you AND an even number with 0, 1 here, we are going to store our values that we test in DX. Take an example of 10. So 10 is an even number. So when we AND 10 with 0, 1, it's going to give us a 0. But when we AND 9 with 0, 1, 9 is an odd number. The result is going to be 1. So so let me use one example here. Let me try to rather run this code. I'm going to do a single step, one instruction at a time. The yellow coloring here shows the instruction being executed at that point, that moment. So when I run that, I've executed AX, PX. So when I run CX, it's going to store the number of counts, which is 10. You can see here. The next instruction now is storing the 10 in DX. So the value of DX is now 10. So when we run this yellow instruction here, the test 10 and 0, 1, it's going to AND the value 10, 10 in hexadecimal with 0, 1. And since it is an even number, the result is going to be 0. So when you run it, the result is 0. And you can see, you can check that from the flags. You can see the 0 flag is set. And the 0 flag is always set when the result is 0. So, so if the result is 0, this instruction that says jump if not 0 is not going to be executed. So you're just going to proceed with the next instruction here. So move CX DX, then you loop, you go back to the initial, move DX there. And every time you run a loop, the counter register CX is going to decrement by 1. So now the value of CX is 09. So you store 09 in DX. So the new value of DX is 9. So you are going to AND 9 with 01. 9 in binary is 1001. You AND it with 01. The result is going to be 1, since it is an odd number. So when the result is 1, and you can check from the flags, let me run. So when you run, when you check the flags, the 0 flag is 0, to mean the result was not 0. So so this jump, if not 0, is going to be executed because the result is not 0. So you jump to the loop X. So let me execute that, and you see we have jumped to X. So in X, we increment AX. AX is storing the number of counts. It's counting the number of what? Odd numbers. Okay. So you have stored the first count AX, which is 1. The first odd number is 9, and that is the first count, 1. Then we find the sum. So PX is going to store the sum of the odd numbers. So the first odd number is 9, you store it in PX. Then you loop. So the program is going to run continuously until you complete the loop. So let me run. So you see the total number of odd numbers is 5, and the sum is 19H. 19H is the same as 20.